Is it loud and clear? Okay, right, let's start. Right, welcome to another edition. Week 3, day 3. Week 3, day 3. Right. So this we'll be discussing the final 20 MCQs and then one structured, one essay. One structured, one essay. Right. Have a look. Okay. The frequency of a tuning fork is 256 Hz. Frequency of a tuning fork is 256 Hz. When it is sounded with a sonometer wire, 3 beats per second were heard. That means the beat frequency is given. Beat frequency is given. When the tension in the wire is reduced, this is your keyword, tension is reduced. Again 3 beats are heard. Frequency of the sonometer wire after reducing the tension is, right. So let's look at the theory, F proportional to square root T. F proportional to square root T, okay, right. Now tuning fork 256 is sounded with a wire. 3 beats are heard. When the tension is reduced back again, 3 beats are heard. Frequency of the sonometer wire. Right, look at the board carefully. So we assume that the mode of vibration does not change. Mode of vibration does not change. Right. So your beat frequency here is capital. One of the two frequencies subtracted. So what is not changing? 256 Hz is not changing. So when I reduce the tension, frequency also reduces. But if you look at this, the beat frequency has not changed. Beat frequency has not changed. So before reducing, also there were 3 beats. After reducing, also there is 3 beats. So the only option is initially frequency F1 was larger, 3 beats. Then what happens is when I reduce the tension, frequency reduces and reaches somewhere here. This difference also is 3. Understood? No? So beat frequency is always the difference. So difference between these two. This can be larger than that or that can be larger than that. We don't know. But they are giving you a small logic conclusion. Tension reduces, frequency reduces, beat is the same beat. So frequency has reduced means from here it will reduce up to here. Then the difference between these two will remain the same. So they are asking you here very simple, after reducing the tension what's the frequency? So if you look at it, I think you can directly get the answer here. 256 minus 3, how much? 253. 253 Hz. Answer is answer number 2. Answer is answer number 2. Right there. Right there. When the tension reduces, the frequency will reduce. When the tension reduces, the frequency will reduce. When the tension reduces, the frequency reduces. Therefore, the final frequency will be less than 256 Hz. The final frequency will be less than 256 Hz. Final frequency will be less than 256 Hz. Okay. Right. Moving on. Look at this. A rod AB is made by connecting two identical metal rods with a thin piece of poor conducting material. The rod is well liked except at the two ends. If a steady flow of heat is maintained from A to B, the variation of the temperature, two identical metal means thermal conductivity is same. this thermal conductivity is less, K2 is less than K1. What can you say? Series connection. Series connection means rate in which heat is transferred is the same. Rate in which heat is transferred is the same. Okay, no? Q dot is the same. Rate in which heat is transferred is the same. Right. Q dot is equal to K times A delta theta divided by L or delta L. Q dot is constant. Area is constant. Look at this carefully. When K reduces, gradient increases. When K increases, gradient will reduce. Gradient will reduce. Now you must select the correct diagram. Initial K is large. K1 is large. Larger K1, smaller temperature gradient. Smaller K, larger temperature gradient. There, larger temperature gradient. So initial and final should be same gradients. Same gradients. Same gradients. Right. So looking at the picture here, well, these two are same, but intermediate problem. No, K2 is small means gradient is large. Larger gradient. These two are same means larger drop. I think answer number 2 is more suitable for this. Answer number 2 is more suitable for this. So here gradient is less. Here also gradient is less. This part gradient is large. Gradient is large. Okay? Right. Moving on. Next question. Heat is supplied at a constant rate to a certain amount of ice. The variation of temperature theta with time is shown in the figure. If the specific heat capacity of ice is C and specific heat of vapor fusion is L, what can you say about the ratio T2 over T1? Right. So here specific heat capacity of ice is given. Supplied at a constant rate. So Q dot is equal to M over T, specific heat capacity. Specific heat capacity, or if you actually consider this carefully here, mass, specific heat capacity, change in temperature. 0 minus minus 20 divided by time is T1. Q dot is equal to MC 20 over T1. Equation 1. Heat is supplied at a constant rate here also. Q dot is equal to M over T2 L. Equation 2. What can you say about equation 1 and 2? Both the heat transfers, heat supplied is constant. 1 and 2 both are same. MC 20 over T1, ML over T2, same mass. ML cancel off. What are they asking you? T2 over T1. T2 divided by T1 is L divided by C20. L divided by C20. Answer number 4. Answer number 4. Write down. The heat transfer is constant. The heat transfer, the rate of heat transfer is constant. Remember, majority of the answer is already there in the question. Majority of the answer is already there in the question. Right. Okay now? Moving on. An ideal gas is kept inside a rigid container. Ideal gas kept inside a rigid container. Variations of pressure inside the container with absolute temperature before adding the second gas and after adding the second gas is. So remember, pressure proportional to absolute temperature before adding the gas. There is a variation. Now it can't be like this. Finally, total gas should be ideal gas equation. So this is wrong, this is wrong. If you extend this, this is also wrong. To extend one will go, one won't go, this is also wrong. So most probably this is your answer. Here. Now in the second situation, two gases. So the total pressure here is P1 plus P2. That is proportional to absolute temperature. That will also go through the origin. This will also go through the origin. Here. Both will go through the origin. So most suitable answer is answer number 2. Right there. Ideal gases obey pressure law. Ideal gases obey pressure law. Ideal gases obey pressure law. And it must pass through the origin. And it must pass through the origin. When we add two gases, the total pressure will increase. The total pressure will increase. But the graph will always pass through the origin. But the graph will always pass through the origin. Right. Okay. Look at this question. Consider following two circuits. V1, V2 are the voltmeter readings. I1, I2 are ammeter readings. If the voltmeters and ammeters are ideal, what do you mean by ideal? Voltmeter, no current passes through. Now we have learned this, we know this. Current means no potential difference. Ammeter means no potential difference. Right. Internal resistance of the cells are negligible. Right. Which of the following is true? Okay. So EMF is given here. Current is passing through, won't go through that, all the current passes through this. All the current passes through there. So we can easily say V1 is equal to I1R. No potential difference here. So V is also equal to E. V is also equal to E, right? What can you say here? No potential difference there. E is also equal to E, right? Equal resistors, this current will divide. I2 current. If you compare I1 current, resistance is half, means current will double. This is 2I1. Across this I1, across this I1. Across this I1, I1. Right. What can you say about V1 and V2? Well, V1 and V2 both will be same E. What can you say about I1 and I2? I2 is larger than I1. So V1 is equal to V2, I2 is larger than I1. Correct answer is answer number 1. Answer number 1. That is equal application. So across this the potential difference is 0. So this voltage should be completely given here. Ideal no current means voltage same. Here potential difference is 0. Potential difference 0 means all this voltage will be given here. Here effective resistance is R over 2. Resistance reduces means current doubles. Resistance is half means current doubles. Current doubles means here 2I. And here another way of saying is here E means here I1, here I1. So here 2I. Right there. In the second circuit, you can see how electricity problems are very easy. In the second circuit, the effective resistance is halved. The effective resistance is halved. The effective resistance is halved. Therefore, the current in the main circuit will double. The current in the main circuit will double. The current in the main circuit will double. Right? Okay. Circuit contains 75 ohm unknown resistor as shown in figure. Internal resistance in the battery is negligible. What are they asking? If the voltage across 75 is 9 volt. Voltage across 75 is 9 volt. Here 9 volt. Which of the following best represents the unknown resistor? So 12 volt here, 9 volt there means across this it's going to be 3 volt. Across this 3 volts. If you are a bit smart, you can quickly find the current in the circuit. Current in the circuit is I. So here I can apply V is equal to IR. I can apply V is equal to IR. So if I apply delta V is equal to I times R, 75 ohm resistor, 9 volt I times 75. I is equal to 9 over 75. No? 9 over 75. So same current will go through this. So if I apply delta V is equal to I times R, voltage is 3 volts, current is 9 over 75. Resistance. 3 times 1, 3 times 3. R is equal to 25 ohm. Now find which combination will give you 25 ohm. Which combination will give you 25 ohm. Here 12.5. Parallel resistors. Here effective is 12.5. Here 75 ohm won't give. Here remember be careful. Short circuit. Here R equals 0. If I do this, current will go across this, not across that. 50-50, here 25 ohm will come. Correct answer is answer number 3. Correct answer is answer number 3. Right? Okay. So what we have done is very simple. Here 12 volt means here 9 volt, here 3 volt. What happens is, if you simplify the relationship, find the current in the circuit here, same current there, you can find the resistance. That resistance, from here you can find. 50-50 parallel means 25 effective. Okay? Right. Moving forward, what is this? Diagram shows resistance AB of an ideal voltmeter. These are key words. Ideal voltmeter means current, no current passes through. No current. So guaranteed no current is going there. Okay. Ideal ammeter. These are also keywords. Ideal ammeter means no potential difference. So no need to worry about the potential drop there. Low issue. While contact P is sliding from A to B. From A to B it's going to slide. Which pair of graphs would correctly represent variation IV text? So first let's look at this. Resistor is there. This is at A. What is your voltmeter reading? What is your voltmeter reading? If you look at the board carefully, be careful, negative terminal on top, positive terminal at the bottom. So this is going to be a positive or negative value, you should know. So normal method is we will, if you ground this point here and this point there, potential is same. Potential is same. No? If I name it, if I name this E, there. If I name this E, E says this, let's ground the negative terminal. To ground the negative terminal, here 0 volt. Here it's going to be E. Look at the board now. Here there is no resistance, here also E. So what's your potential difference? Potential difference is going to be 0. Potential difference is going to be 0. Look at the board carefully. Right. Then what? I'm moving it up to B. Now you might ask me, so why did you ground it? You can normally, to analyze it easily, ground the negative terminal. If you ground the negative terminal, that's going to be 0. So this complete voltage will go on the positive terminal there. Here there is no resistance, so here voltage, same. These are small techniques which you use. Right? Now here, voltmeter resistance or voltmeter is here at B. Now, just as we did earlier, it's easier because if you ground the negative terminal, Here voltage 0 means here voltage also 0. Here E means this part is E. So E and 0 means potential difference is E. Potential difference is E. So across the resistor voltage will vary. V is equal to IR. So voltage varies like a straight line, no? Like a straight line. Y is equal to mx form, no? Don't worry. So now look at this carefully. What can you say about the current in the circuit? Current in the circuit is important. Here current passes through this same current. Here current passes through this same current. No current there. So current is constant. Current is constant. So looking at this, you can say current is constant. This is there. This is there. All these three variables are wrong. All these three variables are wrong. This is wrong. This is wrong. This is wrong. Current is constant. Voltage is increasing. So when I go from A to B, voltage is what? Be careful now. Here voltage is what they are asking. Now V is their symbol for potential difference. V is their symbol for potential difference. So potential difference from A to B is increasing. So correct answer is this one, answer number 1. Correct answer is answer number 1. Right there. So this you can see I am not writing equations. Am I writing equations? No. Very simple circuit analysis. Right there. Across the voltmeter there is no current. Across the voltmeter there is no current. And to analyze the circuit easily, we ground the negative terminal. And to analyze the circuit easily, we ground the negative terminal. We ground the negative terminal. From this, at A and B, we can find the potential difference. At A and B, we can find the potential difference. And as we move from A to B, potential difference will increase. And as we move from A to B, potential difference will increase. Okay, now? So easy, direct answer is answer number 1. Answer is answer number 1. Right. Okay. Two cells EMF E1 and E2 is given. E1 is larger than E2, this is larger than that. As shown in the circuit as negligible internal resistance. For what value of R will ammeter A have 0 current? Ammeter A has 0 current means no current passes here. So if I apply Kirchhoff law for this loop, no current here means potential difference there is 0. Anyway, this you have to consider ideal. Ideal means potential difference anyway 0. Even if it was not ideal, also 0, no current. So this voltage will go across this. This voltage will directly go across that. Now E1 is giving voltage or giving energy to this. E2 is here, so remaining will be across the resistor. No? Remaining E1 minus E2 will be across the resistor. Right. So now you can apply actually and find the current also. Because current will go through only this. Not across that, current is 0. So if you apply Kirchhoff law, minus to plus. Sum of EMF equals sum of potential differences. Minus to plus positive. Here voltage is E2. Voltage is E2, but to make it easier, what you can do is, let's find the current will. Right. Let's find the current. Current times R1, current times R. We don't know how much of this resistor but R. Right. Here current is equal to E1 divided by R1 plus R. Now what's the voltage across the resistor? Delta V is equal to IR across R. Potential difference there is E1 minus E2. Current is E1 divided by R1 plus R times R. Okay. So if you simplify the relationship, what are they asking? For what value of R? You find R. Cross multiply. E1 R1 plus E1 R minus E2 R minus E2 simple R, E1 R. E1 R will cancel out. Simplify this. E1 minus E2, that's R1 into R1. Take it to the other side, that's E2 R. R is equal to E1 minus E2 R1 divided by E2. Correct answer is answer number 5. Correct answer is answer number 5. Okay, no? Correct answer is answer number 5. Right. Again, look at this. No current here means here voltage 0, here voltage anyway 0. So this voltage will go across that. Then there is no current coming this way, all the current will go across this. Apply Kirchhoff. You all know Kirchhoff. Minus to plus. Positive. Here I times R1, I times R. This part will say R1. Current is 1. So here voltage E1, here voltage E2, remaining voltage is here E1 minus E. Current into resistance, cross multiply. Simplify, you can find the resistance. E1 minus E2 times R1 divided by E2. 8-1 correct answer, answer number 5. 8-1 correct answer, answer number 5. Right? Okay now? Okay. Operational amplifier is powered by supply voltage plus 50. So op-amp, they are actually very simple devices. Non-inverting terminal, inverting terminal. So they are given you V0 represents the output voltage. Here minus 15 volt, here we can say plus 15 volt. Generally we say V plus here, we say V minus here. These call, these call non-inverting input, these call inverting input. That's your output. Right. What kind of circuit this is? Is called an open loop circuit. Why? The output has no feedback with the inputs. So it's an open loop circuit. What circuit? Open loop circuit. Right. What are they asking you? If V1, V2 represent the inputs and they are asking the variation V1 minus V2. Look at the board now. You should know what V1 and V2 is, otherwise finish. Remember, output voltage is given open loop, A0, V plus minus V minus. From this we should know V plus is your V1, V minus is your V2. So this is your V1, this is your V2. From there on you know. Right. So the graph is of the form y is equal to what? Mx. So this is not your answer. This is not your answer. This is not your answer. But remember, output can never exceed. Output cannot exceed supply voltage. And supply voltage is plus or minus 50. That means what? Output will saturate. That means output will saturate. That's the whole idea. if the output is greater than plus or minus 50, output will saturate, that means become constant at plus or minus 50. Nothing can exceed the supply. The saturation graph is only here. Correct answer is answer number 1. Correct answer is answer number 1. Right there. These are open loop circuit. These are open loop circuit. And the output can never exceed the supply. The output can never exceed the supply. Therefore, saturation will take place. Therefore, saturation will take place. Normally, if you draw the curve, this is V1 larger than V2, it saturates at the positive supply. V1 smaller than V2 will saturate the negative supply. These are normal things that you all should know. V plus larger than V minus, output saturation at the positive supply. V plus smaller than V minus or V minus larger than V plus, output will saturate at the negative supply. These are very simple things, very, very simple things. Right. Next one. As open. Okay, go back to variance. Wait. Just happen. New content, right? Okay, done. Right, all of you can see this one? Okay. Right. Let's go up. Okay. Right. Which of the following circuits shows which of the following circuit shows or draws the largest current from a 6 volt? Larger current means smaller resistance. So current will travel this way. It can't go, it will go this way and go. Why? We reverse bias. Current in the circuit is 0. Why? Reverse bias. Current will travel through the least path of resistance, this way. Current will go through the least path of resistance, that way. Current will actually divide and go here. So largest current means smallest effective resistance. Here the effective resistance is 3 kilo ohm. Here the effective resistance current is 0 infinity. Infinite resistance current doesn't pass through. Here current goes through 2. Effective resistance is 2 kilo ohm. Current goes through that effective resistance 1 kilo ohm. 2 and 1 parallel. 2 times 1, 2 divided by 3. 0.67 kilo ohm effective resistance. So biggest current will be there in the smallest resistance. Correct answer, answer number 5. Correct answer, answer number 5. Okay. Okay. Write a small sentence. Write a small sentence. The greatest current will occur. The greatest current will occur when the resistance is small. क्या आपने write down? Right. Sorry about it. Huh? That was more technical in the microphone. Right. Okay. All of you can hear, no? Right. As we move along, next one. Capacitor consists of n number of equally spaced parallel conducting sheets. Alternate sheets connected together compose a positive plate and the other alternate sheet composes the negative plate as shown. So here negative plate is there. Here we have the positive plate. I have taught you this. There is a positive plate, you put positive and go both sides. Negative, now this outside is used. So here you go. So here there is electric field, here there is electric field, here there is electric field, electric field, electric field, electric field. That means there are capacitors. Look at the board carefully. N number of equally spaced parallel plates. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 8 plates, 7 capacitors. So n plates, you have n minus 1 capacitors. Don't forget. How are the capacitors connected? Positive terminal like this. Negative terminal like this. So capacitors are connected parallel to each other. Capacitors in parallel are like resistors in series equal n minus 1 A epsilon naught over D. So here your answer is going to be correctly answer number 3. Answer number 3. Okay. Right there. When n plates are connected, there will be n minus 1 number of capacitors. There will be n minus 1 number of capacitors connected parallel to each other. Okay, no? Next one. S1, S2, S3 also are Gaussian surfaces. Plus Q minus Q are given. What can you say about the flux? Very easy now. Flux through surface S1 will be 0, no charge. Flux through surface S2 is going to be plus Q over epsilon naught. So it's going to be positive. Flux through surface S3 is going to be minus Q over epsilon naught. Negative. Flux through surface S4. Sum of charges inside these two cancel off 0. So flux through surface 1 was a 0, 4 was a 0, 2 is positive, 3 is negative. Correct answer number 2. Correct answer number 2. Right. Correct answer number 2. Right there. We must apply Gauss theorem. To obtain the relationship. We must apply Gauss theorem to obtain the relationship. Right now? Okay. Next one. If UB is larger than UA, this thermodynamics. Remember, UB larger than UA, internal energy depends on your temperature. So temperature B is larger than temperature A. Simple. The net work done by the gas is positive for the whole process. Look at the word carefully. Here expansion taking place. Delta Q equals delta U plus delta W. Starting, finishing. One is expansion, one is compression. What kind? Clockwise. Clockwise cycle means network output. Network output means positive. Statement A is correct. So these are your points. Clockwise cycle, network positive. Network is positive. Clockwise cycle, network is positive. Right. So anti-clockwise cycle, network is negative. Heat is absorbed along A to B. Heat is absorbed along A to B. Look at the word now. Delta Q equals delta U plus delta W. A to B, A to B, A to B. Here expansion, work output, here positive. A to B is UB minus UA. UB minus UA. UB is larger than UA. These is also positive. Therefore, delta Q AB is also positive. That means there is a net heat input. Heat is absorbed along path A to B, while heat is liberated along path B to A. Let's see. Delta Q B to A, delta U B to A, delta W B to A. Compression. Compression means network input minus. B to A means UA minus UB. UA is smaller. It is negative. So delta Q BA is going to be negative. Heat input positive, heat output negative. So here heat liberated, correct. Statement B also correct. Statement B also correct. Now look. Third step. Temperature of the gas at the beginning and the end of the process is same as the temperature of the gas at the beginning is same as at the end. What can you say? Beginning and end both are same. Beginning and end both are same. Why? Cyclic process. Cyclic process. Cyclic process, if you mark it here, beginning temperature, finishing temperature, all are same. C is correct. A, B, C all are true. A, B, C all are true. A, B, C all are true. Answer number 5. A, B, C all are true. Answer number 5. These are the logic. Clockwise cycle, network is positive. Here A, B process are separated within, B, A are separated. Starting, finishing both the same. So what? Temperature is the same. Okay, na? Right. Moving on. Electrons are emitted from a certain metal. Electrons are appear from a certain metal. So photoelectric effect. Right. Consider the following statements. Now metal is there. All of you should know the basic rule. Photon incident energy. The electron will do some work to come to the surface. Work function. Electron emitting will have a maximum kinetic energy. So E is equal to incident energy is equal to work function plus K max. So HF over HF naught threshold frequency K max. F is equal to C over lambda. HF naught K max. Right. So these are usual symbols. F naught is your threshold frequency. Threshold frequency, we have talked about this. Only after a particular frequency, electrons are emitted. Incident frequency should be greater than threshold frequency. Photoelectrons will be emitted. Right there. The photoelectrons are emitted. The photoelectrons are emitted only when the incident frequency is greater than the threshold frequency. Incident frequency is greater than the threshold frequency. Right. Question. Kinetic energy emitted is less than HCO lambda. Yes, no. HCO lambda minus HF naught, that is Ke max. So kinetic energy is less than this. So A is correct. B wrong. Kinetic energy of the electrons emitted from the metal does not depend on the material of the metal. Be careful. Does not. F naught depends on the metal. F naught depends on the metal means kinetic energy depends on the metal. Statement B is wrong. Whatever with B is wrong. Whatever with B is wrong. Look at this carefully. Rate of emission of electrons depends on the wavelength. Wrong. Earlier, last week MCQ we had this. Number of electrons emitted. Number of electrons emitted. Get a graph to draw. Number of electrons emitted. That is proportional to intensity. Intensity of light. Only A is correct. Answer is answer number 1. So if you know your theory, you can see how simple it is. So number of electrons emitted depends on the intensity of light, right there. Number of electrons emitted depends on the intensity of light. Okay. Right. Write down reasons, then quickly we can move on. Right. A mass attached to the lower end of a vertical elastic string is rigidly fixed at the other end. The mass is moved down with constant velocity by applying a force F. The variation of force with time is best represented by. So here there is a mass. We are moving it down with constant speed. Don't forget there will be tension. And your applied force will guarantee change. But tension is changing. Young's modulus is equal to stress divided by strain. Here weight of the object is also arranged. Young's modulus is applied force plus mg, where we are in the proportionality limit still. Extension divided by initial length. Initial length is the unstretched length. Unstretched length. First multiply. Young's modulus x over L F plus mg divided by A. Young's modulus A Lx F plus mg. Carefully rearrange this. Carefully rearrange. Now F is equal to Young's modulus A L x minus mg. Minus mg. They are telling you it's going down with constant speed. X is your distance moving. V times t. So F is equal to Young's modulus A L V times t is your x minus mg. Graph is of the form y is equal to mx minus c. Simple ideas. Simple ideas. Check and see whether you have an answer like that. Check and see whether you have an answer like that. Now if you look at it, here guaranteed it won't be this graphs. Can't be these graphs. Here it's y equal minus. I don't think it's a minus graph. So it's a positive gradient graph. Let's go back to the question. Mass attached to the lower end. So already initial extension is there. Alright? move down with applying a constant force. So looking at this, y equal mx minus c. So after the mass is being applied, so if I draw this, let's see from where after the mass is being applied is considered. So after the mass is being applied means when t is equal to 0, f is equal to minus mg, down like. So I think they are considering after the extension from here, not from the beginning, from here the extension. So I consider from the beginning. So they are considering the extension from here. That means no need to consider, effect of mg. No need to consider effect of mg. No need to consider effect of mg. Now y equal mx form. Okay, y equal mx form. So you realize it's not this because they are saying after the mass is hung, from there only the extension. So anyway, we have only one answer here. Correct answer is answer number 1. Correct answer is answer number 1. Okay. Write there small sentence. We are applying from the point of extension. Right now? Okay. So from the point of extension only we are applying this. So clearly if you look at this, from this point only the extension is formed. That is why we can easily get the equation y equal mx form. Okay, no? But actually you must consider from the beginning. If you consider from the beginning y equal mx minus c. So I have given you the perfect answer, but they want the answer only from the extension. Right. Okay. Displacement of the object is given, so this graph is of the form y is equal to a cos omega t. A cos omega t. Right. What do they want? Following graphs best represents the velocity of kinetic energy. So now you all know if the displacement graph is cos omega t, the velocity graph is a omega. I have not told. A comes down, cos becomes sine, minus comes up. A becomes, cos becomes minus sine omega t, omega comes up. That's our velocity. Now kinetic energy is equal to half mv square. Half m velocity squared is a squared omega squared sine squared omega t. Sine squared omega t. So that means it can't be negative. It can't be negative. So guaranteed not negative. If you look at this, at the maximum displacement velocity is what? 0. Velocity 0 means kinetic energy is also 0. Kinetic energy also 0, which means your correct answer is answer number 3. Answer number 3. Okay. Why? Here they are given you displacement graph like this. Maximum displacement here, velocity is 0. Velocity is maximum only at these points, equilibrium position. There. Velocity is maximum only there, right there. As shown in the figure, when the displacement is maximum, the velocity will be 0. When the displacement is maximum, velocity will be 0. Velocity will be 0. And the kinetic energy can never be negative. Kinetic energy can never be negative. Okay. Right. Displacement time graph. Displacement time graph. Okay. Corresponding VT graph. But I think I should draw it here itself easier. So here you go, the VT graph. Positive gradient, positive constant. Zero gradient, zero gradient, zero velocity. Constant negative gradient, constant negative velocity. Zero means here. Positive gradient means are these two parallel? Yes. Where is this graph? Find that graph. Okay. They want the VT graph. I'm sorry. Oh, sorry. I thought this VT graph is acceleration graph. So right. Constant velocity. ST yes, this is ST graph. Okay. Right. So here we have T1 to T2. T1 to T2 0. T1 to T2 0. T2 to T4 negative. T2 to T4 negative. I think there is a mistake in the print. T2 to T4 negative, this should be here. Now, so to correct that, you get the answer here. But as for this, there is no answer, but this should be, I think, connected up to here. There is a small typing here. From here to here. There, from here to here. Then correct. Then correct. Because even the one I drew here, correct, no? 0 to T1, T1 to T2, T2 to T4, T5, T6. Right. Okay, moving on. Question number 18. Question number 18. Two parallel wires, we know this. Wires are in the same direction means attractive. Have a look. Current going there means field is coming outwards. Current going there means field is going inwards. Inwards, outwards will cancel off. There is no magnetic field at the center. No magnetic field at the center. No magnetic field at the center means correct answer is answer number 4. 18, correct number, answer number 4. Here, resultant magnetic field 0. Resultant magnetic field 0. Right? Current there, field outwards. Current there, field inwards. Outwards, inwards cancel off, magnetic field 0. Only this graph is correct. Right. A U-tube shown in the figure accelerates in that direction. Now these are the basic. Whenever there is acceleration, If you draw it, I have got for the ones who came for theory a shortcut. For the ones who don't know this, I'll teach. When you accelerate in that direction, this level goes up, this level goes down. If I take a horizontal fluid layer, this will have a greater height, so greater pressure. Shorter height, smaller pressure, right? When the beaker is accelerating forward, this liquid also should accelerate forward. Here height is h1, here height is h2. So P1 is equal to PATM plus h1 rho g. P2 is equal to PATM plus h2 rho g. Now what? If I apply F equal ma in the forward direction, there is a resultant pressure force here, P1A minus P2A, mass into acceleration, mass into acceleration. P1A, PATM plus H1 rho g times it. P2, PATM plus H2 rho g times it. Mass of this particular section, mass of that particular section, A times L rho into acceleration. Right. A cancel out. PATM cancel out. H1 minus H2 rho g, L rho A, rho cancel out. H1 minus H2 divided by L, A over G. They are saying what? The difference in the level. So right, H1 minus H2 is LA divided by G. LA divided by G is answer number 1. LA divided by G is answer number 1. For the ones who came from my daily class, I taught you a shortcut. Tan theta is A over G. So tan theta means, here you go, this angle here theta. Tan theta is opposite over adjacent. Opposite over adjacent is opposite is what? H1 minus H2. Here H1 minus H2 divided by L is A over G. First multiply. H1 minus H2 is LA over G. So once you don't know, you can write this down. But these are shortcut I have taught all the theory students who came to class. Right. Okay. Right. Let us was understand. When the flat bottom U tube is accelerating horizontally, when the flat bottom U tube is accelerating horizontally, the mass also will accelerate in the horizontal direction. Right now, a long wire ABC is bent to form 60-degree angle and kept in a plane perpendicular to a uniform magnetic field as shown in the figure. Another long straight wire PQ is made in the same material, keyword same material, with the same cross-sectional area, interesting, same cross-sectional area, pulled with a constant velocity on the wire ABC. So this is going forward with a constant speed. So that the triangle RBS is always equilateral, that means these lengths are always equal. Induced current will vary. Now you can apply. Now it's induced Fleming's right hand rule. Field motion current. Field motion current means here I can mark the battery. Let me mark the battery. Current is going positive or negative EMF. So EMF is BLV. Remember there's a reason where they said same material, same cross-sectional area. Why same material, same cross-sectional area? A is same, rho is same. This source has a length, this source has a length, this source has a length. That means here there is a resistance, here there is a resistance, here also there is a resistance. Now this current coming out from here will go across this. It can't go here. Open terminal will come inside. Apply Kirchhoff law. Minus to plus. Sum of EMF equals sum of potential differences. Minus to plus BLV. Current times how many resistors? 3 resistors. I times 3R or I in series. BLV is equal to 3 I times 3 rho L over A. Every resistor is rho L over A. L will cancel out. I is equal to BVA divided by 3. B is constant, V is constant, A is constant, 3 is constant, rho is constant. There you go, constant. So current will always be constant. Current is always constant means which one? Correct answer, answer number 1. Correct answer, answer number 1. Okay. The main idea is very simple here. Let's write it. By applying Fleming's right hand rule, we can find the current passing through the circuit. The current passing through the circuit. Since it's an equilateral triangle, the length of each part will be the same. Which will give us 3 resistors in series. Right? Okay. So right, MCQs are over. Now remember, how many MCQs are finished? 180 MCQs are finished. Okay. Look at the structured essay quickly. Read the structured essay. Figure shows an arrangement used to find the refractive index. Two pins P and Q are placed. The student has not placed the pins properly. How would you place them properly? Right? Now look at this carefully. P, Q. PQ, you can see they are very close to each other. P and Q are very close to each other. Because they are very close to each other. Because they are very close to each other. This is not so suitable. Okay. P should be far away from each other. P and Q. Next, Q should be closer to the surface area. Right. That's right. First one you can say, place Q closer to AB. P and Q must have a considerable gap. Right. Moving on. How would you obtain the emergent ray experimentally? Right. So how do you obtain the emergent ray experimentally? Place your eye here. Move your eye from C to A. At one instant, you will see the images of P and Q in light. At one instant, you will see the images of P and Q in light. At one instant, you will see the images of P and Q in light. Place two other pins in line with the image. Right there. We move the eye from C to A until the images of P and Q are in line. I'll verbally say it easier. Or I'll write it again. Right? We move the eye from C to A until the images of P and Q are in line with each other. Then we place two more pins in line with the image. Of P and Q. In line with the image of P and Q. Then we join those 2 points to surface AC. From there you get the emergent ray. Why is it not possible to use 1 pin instead of 2 pins? So basic to a geometry question. To draw a straight line. Minimum we need how many points? 2 points. Minimum we need 2 points. Okay. Right. Part C. Mark the following angles. Angle of incident I1. I1, reflection, incident, emergent, deviation. Well, best is I'll draw it here. It's easier actually. So here you go. Now, light ray here, I1. Here, R1, R2, I2. Extend this, extend this. Is your deviation. Mark it down to me. Right now? Okay. Write an expression for the deviation. Deviation is I1 plus I2 minus R1 plus R2. For a particular ray, I1, R1 is 6. What's the refractive index? NA sin 10. NG sin 6. But remember, these are small angles. So small angles means sin 10 divided by sin 6. The radians are equal, but here the reality is this. Sin theta is approximately theta in radians, okay, not in degrees. What's the correction? Pi radians equal 180 degrees. So 10 degrees convert to radians means 10 degrees convert to radians means we multiply this by pi over 180. So technically it's 10 over 6, but don't forget pi over 180 radians. Pi over 180 radians. These cancel off, so you get 10 over 6. 10 over 6 is 1.67. 1.67. Right. If the refracting angle of the prism is 60, find the value of R2. Refracting means prism angle. R1 plus R2 is A. R1 is 6 degrees. 60. R2 is equal to 54 degrees. Do you expect to receive an emergent ray from the surface of AC? Answer is no. R2 is greater than the critical angle. R2 is greater than the critical angle. Therefore, total internal reflection will take place. Total internal reflection occurs. Total internal reflection occurs. Right? Okay. Complete the ray. So they have given you the ray diagram. For the earlier one you can draw. So 10 degrees means 6. Total internal reflection takes place. There you go. Right. Okay now? Essay question. Goodbye. A point charge plus Q is placed at the center. Placed at the center. of inner radius 10. Inner radius 10 centimeters. Outer radius 15 centimeters. Points P, Q, R, S and T shown in the diagram are situated P, Q, R, S, T. OP, all distances are given. What are the induced charges on the inner surface and outer surface are marked? Here minus 1 coulomb, here plus 1 coulomb. Isolated conducting sphere. Isolated conducting sphere. So I have marked inner surface minus 1 coulomb. Outer surface plus 1 coulomb. Right. Find the electric field intensities at P, R and T. Sketch the variation of the electric field intensity E versus R. Look at the 3 points P, R, T. P, R, T. Right, let me go back. I need to draw a Gaussian surface. P, R, T. Gaussian surface 1. R. Gaussian surface 2. T. Gaussian surface 3. You can take the variable distance as simple r. Variable distance as simple r. Variable distance as simple r. Right. I think now we should do this properly on the board. Careful, huh? So you can clearly see a very interesting connection. The interesting connection. There you go. Here plus 1 coulomb. If you draw the Gaussian surfaces, you have a Gaussian surface here, you have a Gaussian surface there, and you have a Gaussian surface here. Gaussian surface 1, Gaussian surface 2, Gaussian surface 3. Gaussian surface 3. Look at the board. Let me start applying the equation from Gaussian surface 1. I'll just have a look back. PRT, no? PRT. So here, induced charges. Minus 1 microcoulomb plus 1 microcoulomb. I'm sure you all can see that. Minus 1 plus 1. Okay? Look at the board carefully. Consider Gaussian surface 1. Consider Gaussian surface 1. E times A, sum of charges over epsilon naught. Electric field strength at P, 4 pi simple r square. Remember the variable distance I take as simple r. Variable distance simple r. Sum of charges inside the Gaussian surface plus minus plus. Plus minus plus. Microcoulomb over epsilon. Electric field strength at P is 1 over 4 pi epsilon naught. 1 microcoulomb divided by r square. 9 10 to the power 9 10 to the power minus 6 over r square. Okay now? 1 microcoulomb. Here 9 10 to the power 3 divided by r square. I think that given you OP distance. OP distance is given 20 centimeters. OP distance given 20 centimeters. Substitute here. 0.2 square. Electric 225 10 to the power 3, 2.25 10 to the power 5 Newton per coulomb. 2.25 Newton per coulomb. Right? Okay. Next, Gaussian surface number 2. Once more writing, please write. Gaussian surface number 2. Right. Consider Gaussian surface number 2. Gaussian surface number 2. Here you have E times A, sum of charges of epsilon naught, E times 4 pi r square, sum of charges inside is minus 1 plus 1. Electric field strength 0. Newton per coulomb. Then consider Gaussian surface 3. E times A, sum of charges of epsilon. Sum of charges of epsilon. Here, what's your distance OR? OR is 12.5. OR is 12.5. OR is 12.5. 4 pi 12.5 centimeters convert to meter square. Sorry. OT distance. OR distance is not useful. OT is fine. OT is fine. OT is 5. Five centimeter convert to meter square. Sum of charges 1 microcoulomb over epsilon naught. Electric field strength 10 to the power minus 6. 4 pi epsilon naught 25 10 to the power minus 1. 9 10 to the power 9 10 to the power minus 2. 0.90 you have 3. 150 you have 6. 10 to the power 7. 36. 10 to the power 5 Newton per coulomb. Check and see whether you got this. Check and see whether you got this. 2.25 10 to the power 5. 2.25 10 to the power 5. Here 36 10 to the power 5. That's right. Right. They are asking you to sketch the variation. Sketch the variation. Now if you sketch the variation here roughly, then we can probably do it. Inside here electric field strength 0. Electric field strength outside is over r square. This value over r square. Here if you take it, here also same. If you later substitute for r, same relationship, PRT. Beginning and end, same relationship. So if you plot the graph, here you go. 1 over r square then this middle part disappears. Suddenly the electric field there becomes 0. This is your variation. Clear? So here also E proportional to 1 over r square. Here also E proportional to 1 over r square. I have showed you here. ET proportional to 1 over r square. Here also EP proportional to 1 over r square. In between only 0. Right. Okay. So once you need to draw it, there you go the graph. Please name the axes here 0, 0. Newton per coulomb, here meter. Right. So we are doing a lot of work there. Electric potentials. Check one. Right. Find the potentials at PQR. Find the potentials at PQR. PQRS. Where is PQRS? So I am naming from outside PQRS. So here PQRS. Right. So how do you find the potentials? I have got it. At these locations, how do you find? Very simple. Potential at P. Because of this charge, there will be a potential. Because of that charge, there will be a potential. Because of that charge, there will be a potential. So separately you must write. So what to do? I will keep the same diagram. So what I will do is I will erase this part because we have done this. Erase this part so I can write the potentials there. Okay. I can erase the part so we can write the potentials there. Right. Look. Potential at P. Because of this charge. Where is it? Outside. Take all the charges, keep it at the center like a point charge. 10 to the power minus 6, 4 pi epsilon naught OP plus. Now think about the minus 1 microcoulomb charge. Take all the charges. This point P is outside. So take all the charges, keep it at the center like a point charge. 4 pi epsilon naught OP. Here plus 1 coulomb, where is point P outside? Take all the charges, keep it at the center like a point charge. You can see clearly these two will cancel off. Potential at P is 10 to the power minus 6. 9, 10 to the power 9 divided by OP distance. What is this OP distance given? OP is 20 centimeters, 0.2 meters. 9 divided by 2, 45. 45 10 to the power 3, which is 4.5 10 to the power 4 volt. 4.5 10 to the power 4 volt. Remember, if you are not studying these techniques, you should know these techniques because these are fundamental techniques. Potential at Q. Where is Q? Outside. Take like a point charge. 4 pi epsilon naught, find the potential. From this, it's outside. Keep at the center. 4 pi epsilon naught, distance OQ. 1 microcoulomb on the surface. Keep at the center. 4 pi epsilon naught OQ. These two cancel out. Potential at Q is equal to 10 to the power minus 6. 9 10 to the power 9 divided by OQ distance. OQ is 15 centimeter 0.15. 900 divided by 15. 900 divided by 15. How much? 60. 6.0 10 to the power 4 volt. 6.0 10 to the power 4 volt. Check and see. Check and see. Then they ask it, potential at R, potential at S. Potential at R, potential at S. Be careful. Let's go back to the graph. If they ask you to plot the potential versus distance graph, how will you plot this? How will you plot this? 1 over R squared is actually 1 over R graph. Electric field strength 0 means potential is constant. 1 over R squared means 1 over R. Potential R graph. So if you look at it, from here to here potential is same. Here to here potential is same. So if I go back, QRS potential should be same. QRS potential should be same. Okay. QRS potential should be same. So potential at Q, potential at R, potential at S. 6 10 to the power 4 volts. One shot I have. Using theory, one shot I have. Remember, this is all experience. The ones who you know this, you know. Directly by experience, more than finding here quickly. When you are constant, go and draw the graph. Once you draw the graph, you can see electric field strength 0 means potential gradient is 0. So potential from here to here constant. Here 1 over R square means here potential proportional to 1 over R. Potential proportional to 1 over R. Right. Okay. Now look. So we have found the answers. Answers found. Next question. Sorry. Sketch the variation of potential. Before that, find the electric potential difference between T and S. Hence, find the electric potential at point T. So, find the electric potential difference between T and S. So, PQRS, we have found the potential difference between T and S. Right. You get this clearly. Right. So, all these I have found this one. Potential difference between T and S. Let me have a look where T and S is. T and S is here and here. Potential difference. Okay, nice. Then I have to find the potential at T. Then I have to sketch the variation. Right, sketch the variation already I have done. Anyways, there is part C coming. Let's do this. Potential difference. Okay. Right. So, since all of you have written this, I'll erase it. I'll have to draw the diagram back again. Here, moderation. So, I'll erase this and do one. Right. Well, I've copied the values. Now look. Potential difference between T and S. That is potential at T minus potential at S. Okay. So what is the potential at T? Point charge 4 pi epsilon naught OT. Because of the minus 1 potential inside, he is in a sphere. Potential on the surface and inside both are what? Same. So on the surface, minus 10 to the power 6 4 pi epsilon naught, I'll be taking OS. Because of this, what's the potential there? Potential on the surface and inside both are same. Plus 10 to the power minus 6 4 pi epsilon naught OQ. That's the potential at T. Yeah? This whole thing is potential at T minus potential at S. What's the potential at S? Because of this, the potential there 10 to the power minus 6 4 pi epsilon naught OS. Because of minus 1 coulomb there. Minus 10 to the power minus 6 4 pi epsilon naught OS. S is inside the bigger sphere, same as the potential at the surface. 10 to the power minus 6. 4 pi epsilon naught OQ. Now let's work with this. These two cancel off. If I open brackets minus here, these two also cancel. Finally, 10 to the power minus 6, 4 pi epsilon naught OT minus 10 to the power minus 6, 4 pi epsilon naught OS. That is your potential difference between T and S. OT, OS distances are known. OT distance 5, OS distance 10. So let me find the potential difference. 10 to the power minus 6 common, 4 pi epsilon naught common. OT is 5 centimeters, convert to meters. OS is 10 centimeters, convert to meters. Simplify this. Potential difference between T and S. 10 to the power minus 6, 9, 10 to the power 9. 100 divided by 5. 100 divided by 10. 9, 10 to the power 3. 20 minus 10 is 10. 9, 10 to the power 4 volts. Potential difference is Vt minus Vs. That is 9, 10 to the power 4. Potential X we have found 6, 10 to the power 4. Can remember. From this potential T is going to be 15, 10 to the power 4 volts. 15, 10 to the power 4 volts. Potential difference found. Hence from there potential. There you go. Okay. Potential at T minus potential at S. This is your potential at S. This is potential at T. These two will remain. These two. This and this will cancel. These two will cancel. From this you can build potential difference. From this you can build. So potential at T is because of this, because of that, because of that. You all know the theory? Theory is thought. Where you learn theory. Then you have potential at T, 15 10 to the power 4. Right. 15 10 to the power 4. Then they ask you to sketch. We have done this. You have done that. Back on that graph I have. Okay. Right. Then what? Finally, if an additional charge minus q is given to the conducting shell, find the charge densities. Then I will do this here. Now, they are giving a charge to the shell. Giving a charge to the shell. Here you go. Plus 1 microcoulomb. You are giving minus 1 microcoulomb. Don't forget the induced charges. Induced charges are plus minus 1 microcoulomb, plus 1 microcoulomb. What are they asking? Charge densities. Plus minus cancel out. Charge density. Outer surface. outer surface. Total sum of charges 0 divided by 4 pi the radius there. The charge density is 0 coulombs per meter square. Inner surface, sigma inner. This sigma outer, sigma inner surface. Minus 1 microcoulomb, 4 pi epsilon, 4 pi. What's your radius there? Radius there is OS, I think. OS. OS is 10 centimeter. 0.1 square. 10 to the power minus 2 means 10 to the power minus 4, 4 pi. 10 to the power minus 4, 4 pi. That's minus 79 microcoulomb per meter square. If you write in units, microcoulomb per meter square. Right? Perfect. So outer charge, there is no induced inverse. This is fixed on the outer surface. From the inside only induced charges are. These are your induced charges. Induced charges. Superb question, but it's very easy. Anybody knows the theory? Easily you can score. Easily you can score. Okay. So that concludes week 3, day 3. So how much we have done? 3 weeks. I give a review every week, you know this. 3 weeks what we have done. You will be happy about yourself. These are 3 weeks done. 3 weeks done. How many papers? 2000. 2001. 2002. Done. How many MCQs? Each paper 60 times 3, 180. How many structured essays? Each paper we have done 3 papers, 9. How many essays? Each paper we have done 3, 9. Altogether 180 MCQs, 9 structured essay, 9 essays. Then the day 4, I told you 5th week we'll be doing. I'll remind you on the 5th week. 5th week, I'll be only putting the day 4 papers back again. Because that week will be focusing on that. Okay then. Be proud about yourself if you follow this honestly. If you follow this honestly, that means be proud about yourself. They say if you continue something for 21 days, it becomes a habit. You're very lucky. If you did this, you have continued this for 21 days. But sometimes I get late because I have to come from classes only and do this. Some of you are very eager. By 9 o'clock, message comes. What time is the session starting? Don't worry. Between 9 and 9:30, maximum 9:30, but generally by 9:15, we start. Is it clear? That's because now I have to travel, and after classes, some of you all come to the class, but in the class, then you go home, then I also have to travel back. So that traveling time only is there. Otherwise, generally, Wednesday, Thursday, Friday, this time slot is always fixed. Keep it free. Okay then. Next will be, in order to 2003, 2004. So 2003 paper. Make sure the same intensity you are keeping work. Don't give up. And giving up is not an option. You have no option. And there is nothing to lose. Only things to gain. Is it clear? So never give up. Keep your focus. Whatever level you are, remember that you can make a change in your result. Is it clear? You can make a change in your result. I will try my level best to help you. Is it clear? I will try my level best, my 100% to help you. Okay? Okay then, stay home safe. Keep working. Good night.